All right, so in this video, I want to keep this video nice and simple. I'm just going to do page 13 on this one, and the next ones we'll do more examples. So this is just basically dealing with all the kind of equations that you're going to be using for most of this unit. Okay, so your first one is one that goes back to all the way to the beginning. Okay, so back at the beginning of the year, we have velocity is displacement over time. Okay, so that is one that's just kind of going back. Okay, another one we can use is the one we kind of talk about as far as period and frequency. Okay, so we use this in circular motion. So this was the t equals 1 over f, and f equals 1 over t. Okay, now as far as this kind of unit goes, we're introducing a little bit different. Okay, so still kind of same concept. Okay, first option is, well, if velocity is displacement over time, okay, we can also say that velocity is the distance of a wave over time. Okay, so if you have a wavelength and a time, you can calculate the same thing. Okay, now the more common one, basically the one that we're going to be using a lot in this unit, is velocity of a wave equals frequency times wavelength. Okay, so remember, these are inverse of each other. Okay, this is just kind of a recap. So that means if one goes up, the other one has to go down. Okay, now this equation right here, this velocity is if there is a material medium. Okay, so what I mean by that is, like, is it air? Is it water? Okay, so this one's more common. Usually it will either give you the velocity, okay, or we can say things like sound, which we'll talk about the velocity of sound later. Okay, so you'll know to use this equation, okay, based off the velocity we give you. Okay, and then which takes us to number 5, which is the exact same equation, but instead of v, we're going to say c equals frequency times wavelength. Now this kind of goes back to chemistry. We talked about this in chemistry. Okay, this is when you actually deal with EMR waves. Okay, all the EMR waves travel at the speed of light. Okay, so remember, c equals to 3.0 times 10 to the 8th meters per second. So if they mention an EMR wave at all, okay, you're going to use this one, and you instantly know that velocity is always going to be the speed of light. Okay, we're going to see quite a few examples on that when we come up to that. So again, this is the speed of light. Okay, so remember, EMR waves are the ones that need no material medium, so they can travel through space. Okay, versus your material mediums, that is something where you need it. Okay, like sound needs air or water or some type of medium. Okay, now units we'll see in this unit. If we're talking about velocity or speed of light, okay, that is just going to be meters per second, so nothing new there. Wavelength, remember wavelength is an upside down y or lambda. That is going to be in meters. Okay, frequency, okay, which can be the number of waves per second. Okay, that is in hertz. Okay, and then your time or your period is going to be, which is basically the number of seconds divided by the number of waves, and that will be in seconds. Okay, so let's do a couple of simple examples, okay, and then we'll do more on the next video. Okay, a water wave is propagating at a rate of 10 meters per second. So I just gave you my velocity right there. Okay, and the wavelength is 122.5 centimeters. So wavelength is 122.5 centimeters, but we cannot have centimeters, so divide by 100. That gives you 1.225 meters. So I want to know what the frequency is. So that's your question mark. So velocity equals frequency times wavelength. So I'm going to do 10.9 equals my frequency, which I don't know, so I'm going to leave it as f. And that would be 1.225 for my wavelength. So divide both sides by 1.225, and you get a frequency of 8.89 hertz. And that's your answer right there. Number 2, calculate the wavelength of 103.3 FM waves. So one thing we'll talk about in this unit is radio waves are always in megahertz. Okay, so if you ever want to fix that, okay, all you got to do is just add times 10 to the 6th to make it hertz. Okay, so radio waves are always in megahertz. So if you ever want to fix that, because remember, mega is 10 to the 6th power, just add that to the end. Okay, but the key thing here is we're talking about radio waves. Okay, radio is one of your EMR waves, so that means we're traveling at the speed of light. Okay, so that's one thing you'll notice in the next video is how much I'm going to distinguish between normal waves and then actual EMR waves. Okay, so that'll tell you which velocity to use or when to use 3.0 times 10 to the 8. Okay, so my frequency I'm going to do is 103.3, but I'm going to add that times 10 to the 6th to make it hertz. And then wavelength, I don't know, so that's your question mark. So we're going to use this C equals frequency times wavelength. Okay, so I'm going to do 3.0 times 10 to the 8th equals frequency, which is 103.3 times 10 to the 6th. And wavelength is upside down Y. Now, please be careful when you're typing this into the calculator. When you're having multiple scientific notation numbers like this, please use parentheses when you do your division. Okay, because a lot of times you'll do the actual math right, but your calculator will get confused because you don't have parentheses. Okay, so put both those in parentheses before you divide them. Okay, and that'll give you a wavelength of 2.9 meters. Okay, so if you didn't get that answer, check to see if you put in parentheses or not. Okay, and that'll end this video.